Question number 4. In here the question is saying a track consists of two circular parts A, B, C and C, D, E of equal radius 100 meter and joined smoothly as shown in the figure given below. Each part subtends a right angle at its center. A cycle weighing 100 kg together with the rider travels at a constant speed of 18 km per hour on the track. Find the normal contact force by the road on the cycle when it is at B and at D. Find the force of friction exerted by the track on the tires when the cycle is at B, C and D. Find the normal force between the road and the cycle just before and just after the cycle crosses C. And the last part, what should be the minimum friction coefficient between the road and the tire which will ensure that the cyclist can move with a constant speed. So if we consider this problem, the first thing that we do is we obtain the value of velocity in meter per second. So 18 kilometer per hour can be written as 18 into 5 by 18, which is equal to 5 meter per second. And it is undergoing in a circle of radius 100 meter. So be it arc ABC or be it arc CDE, the value of radius is equal to 100 meter, and the mass of the cyclist which the question is stating is equal to 100 kg. So the things we will be frequently using in this problem is the parameter of weight, which is equal to mg. So we are taking g as 10, so which is come out to be 1000 Newton. And the next parameter which we'll be using is equal to mv square by r. So if we calculate this parameter mv square by r, so I can write it as mass which is equal to 100 into v square upon r, that is 100. So this is equal to 25 Newton. So these are the two parameters which we will be using more frequently in this problem. So if I consider the first one, find the normal contact force by the road on the cycle when it is at B and at D. So if I consider this by drawing a arc like this, so I can say that in the first part over here, the weight of the cyclist is acting in the downward direction, that is mg, and the force mv square r is acting in the outside direction. So at B, the reaction force at B can be written as equal to, and the normal reaction force is acting in the upward direction NB or RB. So I can say that the reaction force B is equal to mg minus mv square by r. And if we put the value, we obtain it as 1000 minus 25, that is equal to 975 Newton. Now at the point D over here, the weight of the cyclist, that is mg, is in this direction, and so is the value of mv square by r. So the reaction force will act in the upward direction, which is equal to rd, and the reaction force rd can be written as mg plus mv square by r. And for this we obtain a value equal to 1000 plus 25, that is 1025 Newton. Now if we consider the second part, the question is saying find the force of friction exerted by the track on the tire when it is at B, C and D. So now at the position B and D, there is no component of weight which is going to act. So the force of friction at B and D is going to be 0. So at B and at D, the value of friction is going to become 0. If I consider at point C, so I can redraw it in this way, that it is subtending an angle of equal to 90 degrees. So this angle over here will become 45 degree for C. So if we draw FBD for the weight of the body, so the weight of the cycle is going to act in this way, that the weight mg is in this direction, and mg cos theta or mg cos 45 is in this direction, and tangentially a force equal to mg sine 45 will be acting, which will be balanced by the frictional force in the opposite direction. So I can say that if it is moving with a constant speed, so at point C, I can say that the frictional force must be equal to mg sine 45. So mg sine 45 can be written as 1000 by root 2. So we obtain the value of frictional force as equal to approximately 707 Newton. Now if we come to the next part, the question is asking find the normal force between the rod and the cycle just before and just after the cycle crosses C. So if we consider this problem, so C is the point where the curvature changes. So C is a point where the curvature changes and the component of weight is equal to mg cos 45 degree, which we have already mentioned over here. So before the curvature changes, the value of mv square by r will be acting in the outside direction, and after the curvature changes to the CDE, the weight, the component of mv square by r will be changing its direction. So I can draw another diagram to make you understand this. So if we again consider this curvature over here, so just before point C, so this is point C which we are referring to. So just before point C, that is somewhere here, the value of the weight is in this direction and the component of weight is in the inward direction, which is equal to mg cos 45, and mv square by r is acting like this. And after it crosses the point C, the component of mv square by r and the component of weight is going to become in the same direction, that is mg, and this component which is equal to mg cos 45 degree approximately, because just after crossing, and mv square by r will be acting in the same direction. So hence I can say that before crossing C, so if I look at point before crossing C, so I can say that the normal reaction force before crossing C, N before, can be written as mg cos of 45 minus mv square by r. So we have already calculated its value as 707 and 25 respectively. So 707 minus 25 will give us a value of 683 Newton, and normal reaction force after. So this is normal reaction force after. So it will become equal to mg cos 45 plus mv square by r. Again we already know the value, that is equal to 25 plus 707, so we can directly write it as 732 Newton. So these are the two parts which were asked. In the next portion it is asking what should be the minimum friction coefficient between the road and the tire which will ensure that the cyclist can move with a constant speed. So in order to make sure that the cyclist is moving at the constant speed, and we need the minimum value of coefficient of friction. So the requirement for the coefficient of friction, or the desired coefficient of friction, we have to consider point C. It is because the point C is the point where the value of normal reaction force is minimum. So if we are solving at C, so I have already made the component of weight which is equal to mg sine theta in the tangential direction. So I can say that the value of mu n, that is the value of frictional force, must be equal to mg sine theta, which is equal to mg sine 45 degree. So we can write it as the value of normal reaction force before crossing we already calculated as 683 Newton. So we can directly put this value, and we can equate this with equal to mg sine 45 degree, which is equal to 707. So if we do this calculation, I can say mu into 683 is equal to 707, and from here we obtain the required coefficient of friction as equal to 1.037. So this become the answer for the last part.